So I just tried to film a bunch of this and then it deleted itself. So that's how my day's going. Let's start over. Hi guys, Catherine here, and today I'm going to be telling you about waves. To start this off, we're going to ask the obvious question. What are waves? The answer is pretty simple. Waves are disturbances that carry energy but not matter. There are two main types of waves, mechanical and electromagnetic. The main difference is mechanical waves need matter, or medium, to transfer the energy, while electromagnetic waves do not. First, let's talk about mechanical waves. Mechanical waves can move in two different patterns, transverse and compression, frequently referred to as longitudinal. Transverse waves move up and down, perpendicular to the motion of the wave. The highest point that the wave reaches is called the crest, and the lowest point is called the trough. The distance from crest to crest, or trough to trough, is called the wave's wavelength. The wavelength is related to the frequency and speed of the wave. The distance between the line of equilibrium and a crest or trough is called the wave's amplitude, or how far the medium moves from rest point. An example of transverse waves are ocean waves. That sounds so stupid. Oh well. The other type of mechanical waves are longitudinal waves. These waves move back and forth as opposed to up and down. They also move parallel to the motion of the wave. Longitudinal waves can be shown in a slinky. We're going to use the slinky on your desks to model a longitudinal wave. Stretch the slinky out and have one person hold one end of the slinky and another person hold the other end. Then have one person make a forward pushing movement with their end of the slinky. You can see that the slinky's appearance changes. When one particle moves and affects the next one, that particle then moves. The first particle then goes back to its original position. Push forward again and notice how areas of the slinky appear to be closer together. The spot where the rings are closest together is called compression. The spot where the rings are farthest apart is called rarefaction. The wavelength of a longitudinal wave is the distance between compression to compression, or rarefaction to rarefaction. One of the most common types of longitudinal waves are sound waves. One particle vibrates, and that vibrates the next one, and so on, until it comes to your ear in the form of sound. Like I said before, mechanical waves need a medium in order to transfer energy. The second type of wave, electromagnetic waves, do not need a medium. Because they don't need a medium, they are the only waveform that can travel in a vacuum, like space. There are three different ways that a wave can change direction. These are reflection, refraction, and diffraction. A very common thing that reflects waves is a mirror. The light waves hit the mirror and then bounce off back so you can see it. Whenever a wave reflects off a smooth surface, the angle that it hits the surface at, it will exit at that same angle. This is called the law of reflection. When a wave goes from one medium to another, it undergoes refraction. The speed of a wave depends on the medium it's in. So when the wave goes from one medium to another, the speed and wavelength of the wave are going to change. This results in a change in direction. This is because the light travels slower in water than it does in air. The speed and wavelength of the wave change, the pencil appears to be broken, even though it's whole. Diffraction occurs when a wave goes through an opening or around an obstacle. The wave must change direction in order to beat the obstacle. The size of the bend depends on the size of the obstacle and the wavelength of the wave. When a wave with a small wavelength goes around a large obstacle, the diffraction of the wave is smaller. But when a wave with a large wavelength goes around the small object, the level of diffraction is larger. Now, let's go over the properties of a wave. Wavelength is the difference between one point on a wave and the same point on the next wave. Frequency is how many waves pass by a given point in 1 second. Frequency is measured in hertz and is affected by the wavelength. Amplitude is simple. It's how far the medium moves from rest position in a mechanical wave. Wave speed depends on the medium that the wave is traveling through. You can calculate the speed of a wave with this equation. Wave speed equals the frequency times the wavelength. Let's try a problem on your own. A wave has a frequency of 50 hertz and a wavelength of 10 meters. What is the speed of the wave? Go ahead and pause the video and work it out. You should have gotten 500 meters per second by multiplying the two variables together. To find the energy of a wave, you multiply a constant, which depends on the medium, by the amplitude squared. This concludes our lesson on waves. Today we learned about transverse and longitudinal waves and the difference between mechanical and electromagnetic waves. We also learned how waves can change direction through reflection, refraction, and diffraction. We went over the properties of a wave and practiced how to find the speed. Thanks for watching! Guys, I finally did it. I finally finished and I didn't run out of storage. So my parents just got home from the beach trip and I think they brought us stuff, and so I'm gonna go and look at that right now. And I'm gonna be happy because I finished, and now all I have to do is edit this video. Transverse waves move up and down, perpendicular to the wave. Transverse waves move up and down. Transverse waves move. Transverse. Also, guys, I had a lot of fun. I can't even explain myself. I had a lot of funny bloopers, but then they were all deleted. Maybe I'll still be annoying. This thing is so gonna fall over. Like, it's so unstable. No. Okay. Where was I? The distance between the line of equilibrium and the crest or trough is called the wave's amplitude. What's the amplitude? The distance between the line of equilibrium and the crest or trough. The distance between the line of equilibrium and the crest or trough is called the wave's amplitude. Why can't I remember this? The distance between the line of equilibrium and a crest or trough is called the wave's amplitude, or how far the medium moves from rest point. I did it. Okay. Let's use your Slinky on your desks to do something. What was that? Stretch the Slinky out and have one person hold one end and the other hold the other. Stretch the Slinky out and have one person other than the other. Catherine, you're so stupid. Push forward again and notice and where the rings are farthest apart is called. There are three different ways that a wave can. There are three different waves. A very common wave thing is a very common, oh my god, what is common? A very common thing that reflects wave. When a wave goes from one medium to another, it undergoes diffraction. I'm almost done. Now you are a wave